In this Algebra 1 video, Chapter 2, Lesson 8, we're talking about literal equations. Our objective is, as the student, I can solve equations for any of their variables, and I can use formulas to solve real-world problems because I will use the properties of equality. Now, what we're going to do here is we're going to make sure we're first going to define literal equations, make sure we know what those are, and then we're going to remind you of the properties of equality. Now, the properties of equality are the easy things. The properties of equality are when you have an equation, you got something over here, something over here. If you have an equation, if you add something to both sides and you add the same thing to both sides, remember that's the addition property of equality. Or let's say we subtracted something from both sides of the equal sign. Well, that's the subtraction property of equality. So same thing goes if we divided both sides by the same thing. So remember, anytime you do the same thing to both sides, so for example, this would be the division property of equality. Anytime you do something to both sides of the equal sign, it's called a property of equality. And I left out multiplication. So if you were to multiply both sides by something, that would be the multiplication property of equality. So we're going to use those, and we're going to use them to solve literal equations. Maybe you're wondering, what is a literal equation? A literal equation is usually it's also called a formula sometimes. It's an equation that involves several variables, meaning you'll have more than one letter. That's what that means. And when you're quote unquote solving a literal equation, it's just like a regular equation. You're going to isolate a variable. You can get something by itself. But you're going to solve them by applying the properties of equality. That's how you get your something by itself. So let's say, for example, look at this problem right here. We have BC, meaning B times C, plus 3G equals 2K. And remember, when they're touching, all those when they're touching, they mean multiplying. And it says we're going to solve for C. Just like any equation, when you solve for something, it means we're going to get it by itself. So we need to get this C all by itself. So that means we need to get rid of everything else that's over here. We need to get rid of the plus 3G. We need to get rid of the B. So we're going to get rid of 3G and B. Those are things we need to get rid of. But we're going to do that using the properties of equality. But what you're going to find out is we can't actually calculate, but we at least can show them. So let me show what I mean. First things first, if you were to solve for C and you needed to move plus something to the other side, in fact, we need to move plus 3G, you would do the opposite. You would subtract 3G from both sides. They'd cancel on the left side, and on the left side you would have BC, equal sign. But now on the right side, here's where it looks different. You have 2K minus 3G. Here's the thing. Normally, we would have numbers here we could do something with. But I think you guys will agree, 2K and negative 3G, those are not like terms. We cannot add or subtract them to each other because they're not like terms. So don't overthink it. You literally just leave them separate. Right, 2K minus 3G. You actually aren't calculating anything. You're just showing what you would be doing according to what you did with the properties of equality. Like we subtracted 3G from both sides. So in fact, I'll leave that in red. So the subtract 3G is still over there. Now, to finish getting C by itself, we gotta get rid of its coefficient. Its coefficient in this case is a letter, it's a B. But do what you would do normally to get rid of any coefficient. You would divide both sides by the coefficient. Divide the left side by B, but now here's a trick. When you go to divide the right side, you have to divide everything by B. You don't just get to divide one of them by B. There's no one term over there. There's no one number over there. So we have to divide everything by B. So they cancel on the left side, and if you do this, you're going to be left with 2K on top, 2K minus 3G, so 2K, I'll even leave it in the color as it's in, 2K minus 3G, and you're going to divide all of that by B. So that is the value of C. That's how you solve for C. We would say C equals all of that. So that's the answer to our question. We have solved for C. I agree it's not a number answer for C, but here's the thing. We had so many unknowns because we had so many letters, we couldn't get a number answer for C, but at least we've gotten the variable C by itself, so as soon as we do know K, G, and B, all we've got to do is plug them in and follow the order of operations and we'll have our answer because all that equals C. So we've isolated it and we've solved this literal equation. Again, I know it may seem kind of weird because we're not actually calculating anything. We're literally just rephrasing things and reorganizing, restructuring our equation, but we're doing it using the properties of equality. We're just not actually able to combine anything. Let's say we have this example. Q minus R equals R, and I want you to solve it for R, meaning I want you to get R by itself. I think you'll agree there's not a single number in this question, so it would be impossible for you to calculate an actual value number. But we're going to be able to just at least get R by itself, and the other side will be some kind of an expression. That's what we're going to do. So to get R by itself, you'll notice you already have two R's. So on one on each side. Do what you would normally do for like the mutant chicken method, meaning let's move our variable to one side. We're solving for R, so let's try to get all of them in one space. So we should move the smaller one towards the bigger one. This one is negative 1R, this one is positive 1R. So the easiest way is to move the smaller one towards the bigger one. You'll avoid the negative. So if you add 1R, or just in this case just add R to both sides, cancel on the left side, and on the left side you're left with Q equals. And on the right side you have 1R plus, that's just 1R again, well that's going to be 2R. So you're left with Q equals 2R is what you're left with. And now to finish getting R by itself, you're going to get rid of its coefficient now. You're going to divide both sides by 2. Cancel on the right side. And so now you're left with R equals Q divided by 2. So Q divided by 2. That is an ugly Q. Q divided by 2. So now that's your answer for R. So you would say R equals Q divided by 2. You've isolated R. You've solved this literal equation. Now, yes, you can say that answer in a slightly different way. You could say it. You could also state it as R equals 1/2 times Q. 1/2 times Q means the same thing as Q divided by 2. Multiplying by half is the same thing as dividing by 2. So you've now solved this literal equation. So now this example on the right, I want you to try this example. Your job is to solve for y, meaning get y by itself. So give this one a shot. Press pause. Okay, if this were an equation we were solving for y, the first thing we'd have to get rid of is the item away from the y. Because remember, the last thing you get rid of is the coefficient when you're getting a letter by itself. So in this case, we got to get rid of positive x. Well, the opposite of positive x is negative x. We know it's positive because there's nothing in front of it. So we're going to say minus x, so we're going to subtract x on both sides. They cancel on the left, so on the left side, we're left with negative 2y. And on the right side, we have 1 minus x. Those are not like terms, so we leave them separate. It's literally just written as 1 minus x. That's it, nothing to compute. Now, to finish getting y by itself, we need to get rid of its coefficient, negative 2. How do you get rid of all coefficients? Well, you divide. So divide both sides. But now here's the trick, though. Remember, like we did in the example over here, you have to divide everything, in that case, by b. So in our example, we got to make sure we divide everything on the right side by negative 2. So everything on the right side by negative 2. So it cancels on the left. And on the left, we're left with y equals. Now on the right side, we have 1 minus x divided by negative 2. That's going to be what we're given on the right side. Now, if you can write this in a slightly simplified way, which you can, go for it, because that would help give you a more simplified answer. But at this point, you do technically have y by itself. So let's think of some other ways we can write this answer as well. Or, what is? Go ahead and do everything up top divided by negative 2 if you can simplify it. For example, positive 1 divided by negative 2, well, that's just negative 1 over 2. So we could say negative 1 over 2, so that's a fraction. And then we have negative x divided by negative 2, because remember, it's everything divided by negative 2. Negative x divided by negative 2, well, a negative divided by a negative is a positive, so we could say plus, since it becomes a positive, and then technically, x has a coefficient of 1 right there, so we can think of that as 1x, negative 1x, well, we already said it's a positive, so you can ignore the negatives now. 1x divided by 2, well, that's also known as 1 over 2 times x. So if you imagine that there was a 1 right there, and you had 1x divided by 2, 1x divided by 2 is the same thing as half times x. So, because remember, 1x divided by 2, that's saying 1 times x, meaning x, and then divided by 2 just means divided by 2. So it's essentially saying x divided by 2. And just like we said in our last example, when you divide by 2, it's the same thing as just saying times by half. So this is another possible way to write the answer for the you try example. I guess I would make that number 3. I guess I should have numbered it. So that's another way of writing it. However, for the sake of simplicity, it's not the end of the world if you have something that is that quite simplified for what we're doing. But if you get it most of the way, however, if you can get it most of the way, great, as far as you think you can go. But at least you get most of the way, that is okay. Alright, so let's do the same process, but let's do it for a formula. If you need to hit pause and write some of this question down first, go ahead and do so. Okay, so our question says the volume of a box V is given by the formula volume equals L times W times H. In other words, length times width times height. And that sounds familiar, how we find the volume of a rectangular prism. So a box is just a rectangular prism. So the volume equals length times width times height. So now our first instruction is solve for H, meaning solve for the height. We're solving for the height of this. So to solve for H, so we're going to take that formula and we're going to get H all by itself, which means we're going to get rid of L and W. So use your inverse operations, use your properties of equality. Look at this. It's L times W times H. In other words, it's H times LW. So think of LW as the coefficient almost. To move a coefficient or to get rid of multiplication, we're going to divide. So what we would do is we would end up dividing both sides by LW, since that's the coefficient we're moving. So divide both sides by LW. That is really tiny and sloppy. Maybe I should be writing it again. Okay, so LW cancels on the right side, so LW is gone. So on the right side we have H, but now on the left side we're left with volume divided by length times width. So if we know the volume, we divide it by length times width, that will give us the height. That's how we find the height of any rectangular prism. So now, let's actually use that. So if you were to do part B says, what is the height of a box with a volume of 50 cubic meters, a length of 10 meters, and a width of 2 meters? And this would actually be a word problem. They would actually list these out with words. I went ahead and just abbreviated them down to some of the math ways of writing the same thing. So we're finding the height of this box. But hey, if we need to know the height, apparently all we need is the volume, the length, and the width. So let's see. Volume, length, and width. Oh, that's what they gave us. They gave us everything we need. And by the way, that'll happen if you have a formula. If they give you everything but one of these items, you'll be able to find whatever was missing. So in other words, you're plugging for what you don't. You're plugging for what you know, and you're solving for what you don't know. Anyways, so let's plug this into our new formula, what we know. So if we plug it all in, we plug in 50 for volume, 10 for length, and 2 for width. We have 50 over 10 times 2. Now just follow the order of operations with what you can simplify it over there. And you'll have 50 divided by 20. So 50 divided by 20. Find out what that equals, and that's going to be your answer. 20 goes into 50 2.5 times. So you could say 2.5, or you can say 2.5. So 2.5. We were talking meters in our question, so 2.5 meters. So our height, the height of our box, of our rectangular prism, is 2.5 meters tall. That's how tall it is. We solved for the height. Now, I want to point out, what we're doing when we did this literal equation, when we just did it with just the letters over here solving it, it's what you would have done if you were going to solve this question anyways. So volume of 50, length of 10, width of 2. If you plug those into the formula, so we said volume of 50. So if you put 50 right here, and then you plug in for length and width. So length was 10, width was 2. So literally, if you just plug this in and then you solve this for H, what we did in our literal equation, that's what you would be doing. So and to solve this literal equation, what we normally would have done is, since we have numbers, we would have simplified this first. We would have said 20. So we would have had 20H equals 50. Well, 20 is length times width. We just simply simplified it because we actually knew the numbers. And to finish solving from here, we would divide both sides by 20. So look what we ended up doing. We ended up doing volume divided by 20. Well, that's length times width. That's how we got 20. So what you would have done to normally solve this question anyways, and by the way, you would still get 2.5, but what you would have done to solve this anyways, you don't necessarily need to write this, it's going to be the same steps that you did for your literal equations. So when you solve literal equations, you're going through the steps that you would have done if you had actually known what those things were pretty much and you were solving. You just don't get to combine them and get 2.5. you're just going to have to be left with the literal equation like that. So we're going to pretty much end the video here. I just want to give you an example of showing you how we could have done literal equations but with formulas as well. So remember, when you're doing literal equations, you're solving them and you're just getting whatever letter it's asking for by itself. And with a literal equation, you will literally not have an answer, but you have literally done the properties of equality. You just don't get to combine anything. And so we did some examples of solving literal equations for a specific letter. Now, then you also can do this for formulas. Get a particular letter by itself in a formula. And we pointed out that what you would do to solve that literal equation is what you would have literally done if you had actually just plugged in for that formula and then solved for the thing you didn't know. And so you still would have done the same processes, meaning whatever is in front of it, you would have divided both sides by it, and then you would have gotten it by itself. So it's the same process. So literal equations literally are our equation solving skills, but often we will have letters that we can't combine everything with, so we just have to simplify it as far as we can go. Alright guys, take care, practice this, stick to the properties of equality.